There's a certain sense of urgency about what we're doing on the planet, and I think we need to start being more proactive about it.
Oh boy, now I have multiple things to deal with. So I'm going to try to give you a little nuts and bolts of what's happening with regard to the science surrounding climate change. This technology is getting me. It actually started way back in the early 1900s when we started studying the property of different materials, including gases. We realized that gases have different properties, and some of them have a greenhouse property. CO2 happens to be one of them. This was known, it's generally well accepted, but it wasn't until the 50s that we started thinking, wow, we're putting a lot of carbon into the atmosphere, I wonder if it's building up. And then it wasn't until the late 80s that really with the occurrence of this magazine, do you remember it coming out? It had quite an attractive cover. 1988, National Geographic had this provocative title, Can Man, and it's teaching at a women's college. I take exception to that, except most men did cause the problem. Can we save this fragile planet? And Scientific American also had a similar sort of publication. The arguments have gone like this for the last, well, since that time, 24 years. There's not been any warming. So don't say there is, and this was complicated by a satellite set of data that didn't make sense, but it was because the orbit was wrong, not because the data were wrong. Then the argument was, well, yes, there is some warming, but it's natural. The Earth has natural cycles, and we're just going through some of them. And then there was, well, let's not do anything until we study it some more. And ironically, the climate change scientists thought this was a good idea. And then here's the Bush, the lesser administration. Yes, it's real, but it's too expensive to deal with. It's bad for the economy, so we're not going to do anything. And then just recently, this summer, the humans are the cause. It's now generally recognized. But, oh well, we'll adapt, right? And if you don't believe me, it comes from the CEO of Exxon. So even though there's this perception of a debate, there really isn't. Talk to the insurance companies, talk to the big business, they know what's going on. And, but now the strategy is one of adaptation, not doing anything in particular. It started this way. This is Cleveland skyline in the 30s. It turns out when you burn fossil fuels or any carbon-based material, you produce CO2. It's simple chemistry, simple oxidation process. This fellow, Charles Keeling, was getting out of graduate school and started a career at Scripps, and he made a case that we should probably start trying to measure whether or not all this carbon dioxide that we're putting into the atmosphere is actually building up in the atmosphere. And so there are a couple of places this CO2 can go. One, it can be reabsorbed into the biosphere by trees, through the process of photosynthesis. It can also be absorbed by the oceans. Turns out that's a problem, that's a separate problem. But most of it goes into the atmosphere. So he went ahead and said, okay, in the late 50s, let's find a place. He chose Mauna Loa because it's not anywhere close to any industrialization. It's out in the middle of the ocean. And let's start collecting air samples. And when he did, he started seeing that the parts per million of carbon dioxide were like 280 or something like that. And it started to show this zigzag pattern. Since that time, the CO2 levels, as you can see, have risen. And this is a direct result of us putting CO2 into the atmosphere. We are now way up here at 394. And so this gives you a sense of how much CO2 we are adding to the atmosphere. And the zigzag, the seesaw pattern is in fact the annual cycle of northern hemisphere vegetation during the summer and then decay in the wintertime. We can extend this record back in time by looking at ice cores, in particular Greenland and Antarctica. And when we do that, we see that in fact the record goes back to pre-industrial times when the CO2 levels were more like 280 or so. And again, there we are, way at the top. We can extend it even further back because now we have ice cores from Antarctica that go back about 1 million years. And in fact, we can see a very intimate relationship between the CO2 that was in the atmosphere and the temperature, the air temperature at that time. And you can see that when it's cold during the ice ages, we in fact have lower levels of CO2, and when it's high, we have higher levels of CO2 and warmer temperatures. And again, this is where so this is the natural range of variability for the last 300 and some thousand years. We are now up at this level. We are way beyond the natural range of variability of the natural system. We are pushing the system in a place that it hasn't been to for millions of years. How are we doing this? Why are we doing it? This is the record and the projection of both energy use and CO2. This is domestic product here. It's because we have been using increasingly, and will continue to use, unfortunately, increasingly more fossil fuels for all of our activities on the planet. And this will be taken over largely by developing countries who aspire to have a lifestyle like the Western world. This is not my data. This happens to be data from BP. This is their energy production, their outlook from this year going out to 2030. Climate models are the cloudy crystal ball that we gaze into to try to understand future climate. You can't measure future climate. You hope to calculate it by understanding all the variables enough to predict what will happen in the future. Each of these colored lines represents a different climate model from a different lab, and they make different assumptions about how much sea ice melts and how much the methane is released from the tundra and so on and so forth. But all of them show an increase. You can quibble, it's 2 degrees over the next 100 years, or it's 5 degrees, but none of them suggest that the temperature of the planet's going down. This is probably the most scary plot that I'll show today. The brown line represents CO2 levels going out beyond 1,000.